Today we are going to recap triangle properties and angles. We'll also learn how to calculate sides of triangles using Pythagoras' theorem. So a quick recap, the different types of triangles are labelled alongside over here, and there are quite a few different types. We have equilateral triangles, right-angled, isosceles, scalene, acute-angled, and obtuse-angled. Now in trigonometry, and what we're going to be using in this topic is we're going to be using right-angled triangles. So that's these guys here. So what is the sum of all interior angles inside any triangles? Give you a moment to think about it, but hopefully what you've said is 180 degrees. So with right-angled triangles, we want to be able to label the sides in a right-angled triangle, and we want to have some sort of terminology using the word hypotenuse. So what is the hypotenuse? The hypotenuse is the side opposite the right angle. Alright, so you can say that you have legs coming off of your right angle, and it's the side opposite we call the hypotenuse. So for the below triangles, I would like you to have a think about what sides in these triangles here are the hypotenuse. So pause this video, have a think about it, and then once you're ready, press play. So the hypotenuse are the sides opposite the right angle, side opposite the right angle, side opposite the right angle, and here this one looks a little bit like an isosceles perhaps, but we have a right angle, so we know our hypotenuse is this side at the bottom. So let's get into Pythagoras' theorem. In a right angled triangle with hypotenuse C, so that's this side on the opposite side to our right angle, you have legs A and B, so they are the parts that are branching off of your right angle. Then C squared is equal to A squared plus B squared. So that is your hypotenuse side squared is equal to your two other sides squared individually. So let's do some examples on how we can calculate side lengths using this. So if I want to find the length of the hypotenuse in this very first question here, so the very first thing we want to do is we want to label our hypotenuse. So that here is C. So using Pythagoras' theorem, we can do C squared is equal to A squared plus B squared. Now at A and B can be either of these sides. So I'm going to call this A and 3B, but you could, if you wanted to, swap them around. Right, it doesn't matter as long as your A and B are your two different legs of your right angled triangle. So now that we know what A and B are, we can write this down. So we're going to have C squared is equal to, so A is 3, so we've got 3 squared, plus B, so B is 2 squared. So if I do 3 squared plus 2 squared, right, that gives me a total of 13. Right, so you can just put that in your calculator. And then C is equal to the opposite of squaring. So opposite squaring is square rooting. So C would be equal to the square root of 13. Remember, you always have to do this last step. All right. So make sure you are square rooting. The number of times I see people not square rooting is a little bit disturbing and unfortunate. Okay, in this other example, we want to find the length of the third side of the triangle. So the thing to notice here is that this 6 is our C. So if we were to label all of our values, we know that C, our hypotenuse, is opposite our right angle. So we know that for sure. The other thing now is, well, if I have one of my legs as 5, I can call that A, could also call it B, doesn't matter. So if I call that A, that means my other side is going to be B. So what is our equation? It is C squared is equal to A squared plus B squared, and we can sub all of our numbers in. So C is 6, my A is 5, and my B is unknown at this point. So let's rearrange this. Or maybe we want to do our squared first. It doesn't really matter as long as we get b by itself in the end. So what I'm going to do, I like to do my actual squaring of everything first. So 6 squared is 36 is equal to, what's 5 squared? Well, that's going to be 25 plus b squared. So then we can minus away 25 from both sides, and that leaves us with 11 is equal to b squared. And then finally, to find what b is, we square root both sides. So b is equal to the square root of 11, but if you like writing b first, you can write it like this as well, and that makes no difference. Alright, hopefully that helped.